In this part of video, I shall be discussing on the shapes of atomic orbitals, Aufbau Principle, Paulis exclusion principle, and Hund's rule. Okay, so the first one is the shapes of atomic orbitals. Okay, before moving on to the shapes of the atomic orbitals, let us learn one relation. Okay, that is about the orbital angular momentum. Okay, so the orbital angular momentum is given by the relation L into L plus 1, okay, h by 2 pi. Okay, this is the relation for calculating the orbital angular momentum. Now moving on to the next one, that is the shapes of atomic orbitals. Okay, so in the shapes of atomic orbitals we have the following type of orbitals. Okay, so we have s orbital, we have p orbital, we have d orbital, f orbital, and so on. Okay, in this video let us deal with two types of orbital. One is s orbital and the other one is p orbital. Okay, that is the shapes of the orbital. I want you to check out the types of d orbitals, the shapes, and also regarding the orientations. Okay, so the first one is the s orbital. Okay, the shape of s orbital is spherical. Okay, the shape of p orbital is dumbbell. Okay, is dumbbell. Now in p orbital there are three orientations, that is px, py, and pz. Okay, for p orbital there are three orientations. So here px will be oriented along x axis, py will be along y axis, okay, and pz will be along z axis. Okay, now the next one is the shape of d orbital. Okay, so I think I'll just show you a few things, okay, about d orbital. See, d orbital have following type of orientations, that is dxy, okay, dyz, dzx, dz square, and dx square minus y square. Okay, let me show you dxy. Suppose this is x axis and this is y axis. Okay, then dxy means, okay, this will be the shape of the d orbital for dxy. Okay, then if it is dyz, okay, then the shape will be dy dz. Okay, so the loops will be between the two axes, okay, that is of y and z, or here x and y, okay, here y and z, and for z and x, and so on. Okay, now I want you to find out the structures or the shapes of dz square, dzx, and dx square minus y square. Okay, now moving on to the next one, that is Aufbau Principle. Okay, so the next three topics are the rules. Okay, so in Aufbau Principle, the filling of the electron is the filling of the electron is in such a way that the electrons will be first filled from the lowest energy level, okay, or the electrons will fill the orbitals having the lowest energy level, then only accordingly to the next higher energy level. Okay, or in other sense, it states that the electrons in an atom are so arranged that they occupy orbitals in the order of their increasing energy. Now in some cases, okay, in some cases if the energy is same, okay, say like Okay, now in some cases, okay, for filling up the electrons, okay, we apply two rule. Okay, the first one is n plus l method. Okay, so for example, see, between 4s and 3d, okay, either electron will first fill here or here. So this one, in order to find out whether to fill in this orbital first or this orbital first, we shall apply this one. Okay, so here you see this one is 4 plus s is 0, okay, which is equal to 4. This one is 3 plus spd, okay, so this is 2, so it is equal to 5. So here 4 is less than 5, isn't it? Therefore the electrons will first fill in 4s orbital, although 4 is the 4 represents the fourth shell, okay, and 3 represents the third shell. So first comes third shell, then only fourth shell, okay. But then here, according to Aufbau principle, okay, by applying this rule, first electrons will be filled in the 4s orbital, then only it will go to 3d orbital, okay. Now when the two orbitals have the same value of n plus l, okay, if both the orbitals, okay, if both the orbitals happens to be of same value, okay, then the orbital having the lower value of n is filled first, okay. Suppose there might be some cases where both the values, okay, here we are getting 4 and 5, but in some cases you may get same number. In those cases you will fill the electrons first in those orbital where the n value is lowest, okay. So the method of filling the orbital, the method of filling the electrons in the orbital is of this order: 1s2, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, okay. So I want you to arrange this one, okay, according to their increasing energy, okay. I'll give you the task for this one, okay. Then moving on to the next principle, that is Paulis exclusion principle. Paulis exclusion principle, okay. So according to this principle, it states that no two electrons will have the same values of all the 4 quantum numbers, okay. See, suppose 2 electrons, okay, 2 electrons are present in 1s orbital, okay, 2 electrons. So if we consider the 2 electrons which are present both, okay, so suppose this electron, you name it as electron A and electron B, okay. Now in 1s orbital there are 2 electrons, so we shall compare these 2 electrons, okay. So let us name it one as EA and the other one is EB, okay, electron A and electron B. So here see, both are present in the first shell, that is K shell, both are present in K shell, same, isn't it? N is equal to 1, then L is equal to 0, which means s orbital, both are present in the same orbital. Then next comes M is also 0 only, okay, for both of them. Then spin, one of them will have plus half, the other one of them will have minus half. So therefore, see, from this example we come to a conclusion that according to Paulis exclusion principle, no 2 electrons will have the same value of all the 4 quantum numbers. So at least one of the value of quantum number will be different, okay. Then the last one is the Hund's rule, okay. So it is also known as Hund's rule of maximum multiplicity. Okay, so see, in this rule it states that if more than one orbital of equal energies are present, okay, which are called the degenerate orbitals. Say suppose p orbital or d orbital. Okay, see here in p orbital there are three types of orbital. One is called px, py, and pz. In d orbitals there are 5 types of orbital. One is called dxy, dyz, dzx, dx square, and dz square, and dx square minus y square. Isn't it 5 orientations? Okay, so in both of this type of orbital, okay, see these 3 orbitals are of same energy. They are called degenerate. Okay, degenerate orbitals. And here these 5 are degenerate orbitals. Now whenever we encounter this kind of orbital having same energy, then the filling of the electron is in such a way that first they will all be singly filled along the same direction. Okay, so first they will be singly filled and then only they will pair up. Okay, so suppose here, so first they will all singly filled, then if the single filling is full, okay, in this d orbital or p orbital or any other degenerate orbital, then after the after the electrons are singly filled, then only it will come for the pairing up. Okay, if suppose in p orbital there is only 5 electrons, then how we do is like this: first 1, 2, 3, okay, then only 4, 5. You will have to pair up. Now whenever you are filling the electrons singly, okay, so first in the same direction, okay, all the directions should be of same type, okay, then only pairing up will be another same, like opposite direction of the first one. Okay, so that is how it is done. Now the next one is, see, from this video we have already learned the basic things, okay, for the generation of the electronic configuration. Okay, so let me give you one example and I'll give you 1-2 tasks, okay, to complete it. So let us take helium atom. Okay, helium atom atomic number is 2. Okay, therefore the electronic configuration of helium atom is 1s2. Okay, and if you want to represent in the box notation form, then it will be like this. Okay, and you can write here 1s. Then suppose say like lithium. Okay, lithium atom 3. Okay, atomic number is 3, therefore the electronic configuration is 1s2, 2s1. So in block notation, in box notation, it will be like this. Okay, but then you have to mention this one, you have to mention like this only, 1s and 2s. Okay, this is for block notation, so you have to represent like this for lithium. Now I want you to do for carbon, nitrogen, and oxygen. Okay, find out the electronic configuration, write both this type of electronic configuration and also the the box notation form. Okay,